All right, today we're taking a look at 1/6, you guys. 1/6 is all about solving compound and absolute value inequalities. Keep in mind, Algebra 1 was kind of running through those basics of solving compound and absolute value inequalities. Today we're going to involve a few more special case situations. So, important to keep in mind, compound inequalities can be an and situation or an or. When you relate it to kind of that Venn diagram idea, all right, the and situation is going to be both, or is going to be everything, okay? So just keep that in mind, especially helpful when graphing. And situation, you are looking for the overlap of your two solutions, or you are looking for everything. So let's dive right into the first example. Again, typically, you probably should be quite familiar with this. If it helps, you're welcome to do the railroad tracks, because as you're solving, when you want to get y by itself, you need to add 7 to all three parts. So you're going to have 15 is less than 3y is less than or equal to 30. Then we're going to divide, again, each part by 3. 15 divided by 3 is 5. 3 divided by 3 is 1. 30 divided by 3 is 10. So my answer is 5 is less than y is less than or equal to 10. If I was using that interval notation we talked about yesterday, I would have a 5 is the leftmost, 10 is the rightmost. Since I have a closed circle at 10, I would use that bracket, and I have an open circle at 5, I'm going to use the parenthesis. So again, I'm just going to show you that interval notation and then our standard notation. Typically, we're not going to be focused as much on that set builder notation we talked about yesterday. So that's your answer. It says we can graph our solution on a number line. So at this point, if you're going through things, I would plot 5 and I would plot 10. The nice thing about those, you don't need to add any other points, but I have an open circle at 5 and I have a closed circle at 10. And that's your first compound inequality. This is an and situation. You're looking for all the numbers that are greater than 5 but less than 10. Notice the overlap of the two is between 5 and 10. Continuing on to the next example. This is going to be an or situation. Don't let this confuse you. All right. We just have two inequalities to solve. So when I move the 6 over, I'm going to have k is less than negative 10. Sorry, that looks like a line part of the answer. On this side, when we divide both sides by 3, I get k is greater than or equal to, oh no, a fraction. It's okay. Not a big deal. But those are your two answers. Graphically, all right, I know negative 10 is over here. I'm going to put 0 in the middle. 14 thirds, if you think about it, that's a little over, or it's almost 5, rather. Okay, so if I was just to approximate this, less than or equal to negative 10, and then it would be right about there, and greater than or equal to means a closed circle, sorry, not an open circle. And then, like I said, if we are going to use that interval notation with our left solution, it goes to negative infinity and then it comes up to negative 10. Open circle and infinity both mean sets of parentheses. To include the second part of our answer, we have a closed circle at 14 thirds. It goes to positive infinity forever, which is a parenthesis. So again, we have that standard way of notating our answer. We have our interval notation way of notating our answer. This is super important going up into higher levels of math. You're going to see that a lot more. All right. That was an or situation. Again, As we continue on, we'll dive into absolute value inequalities. Keep in mind, just like before, absolute values and inequalities typically have those two answers. As we are solving, the goal of absolute value inequalities is to turn them into a compound inequality, because absolute values are essentially two inequalities. So we need to set up the compound inequality. When we see a less than or a less than or equal to symbol, you want to keep in mind this is an and situation. So we're looking for a distance that's within 5 units, if you will. Okay, a distance that's within 5 units. This is always going to be your and situation. So as we're setting this up, there's 2 ways you can do it. Typically the easiest way is just to sandwich it between 5 and -5, because we want our distance to be shorter than 5 units. The other way you could do it, if you don't want to do it that way, is break it up into x plus 2 is less than 5, and also x plus 2 is greater than -5. Keep in mind, however, if you do break it up into these 2 inequalities, when you get x is less than 3 and x is greater than -7, the reason I kind of caution you about breaking it up like this is it's an and situation. So don't forget at this point to bring your answers back together. Okay, because an and situation, we're going to have that overlap of the 2 we're looking for. It's not 2 separate answers, it's the overlap of the 2, which is between -7 and 3. If I'm using that interval notation, I'm going to put -7 and 3. They're both open circles, so I'm going to use parentheses. All right, and situation. If you were graphing on a number line, again, you might catch that about putting things back together. But if we had -7 and 3, you'd see that you have an open circle at 3 going that way, an open circle at 7 going that way. The overlap of the 2 is between -7 and 3. All right, but just, again, be cautious. And situation, you want to put your answers together. Or you could set it up like the original compound inequality and solve. Either way, you're going to get the same thing. All right. Next situation, we're going to divide both sides by -3. Keep in mind, when we divide by a negative, we need to switch the inequality sign or reverse our inequality. Okay. At this point, most of you, or not most of you, I should say, some of you will probably just continue on and you'll be like, oh, less than is an and situation, so I'm going to say x minus 1 is less than -3. X minus 1 is greater than +3. You're going to solve, and you're going to find out that when you get your answers, sorry, maybe I'll actually finish this out. So you're going to have x is less than -2. Add 1, we're going to have x is greater than 4. So then when you go to the number line, you're going to have -2, you're going to have +4, +4, -2, shading that way, okay? So if we continued our process, we broke it up into our 2 inequalities, we solved, we found that x is less than -2 or x is greater than 4. Keep in mind, I just said the word or, but if we go back to the original problem, it's a less than symbol, which is indicative of an and situation, okay? As I go to my graph after I solve, notice there is no overlap here, so there is actually no solution, okay? And if you were paying attention, some of you might have seen this already before I continued on. Absolute values can never be smaller than negative numbers because they're always positive. So if you were to stop up here and say no solution, you're right, okay? But then keep in mind, if you didn't see it at that step and you kept going, please know that it was an and situation and you're not seeing overlap on your graph, you still should get to no solution as your answer. So if you didn't catch it right away, continue solving. There's still a way to find your answer is no solution, okay? Because there is no overlap. So just be mindful of those special cases today, and you're looking for the overlap. If there's no overlap, then you're going to say no solution. If it was an or situation and you had the whole number line, let me just kind of give you a situation like this. So we have a situation like this where you have your number line and then you have your answers that kind of overlap and then continue on forever, but this is an or situation. You would actually just say all real numbers because it can be anything and it will always work on your number line. Okay. Be mindful of those special cases. We'll continue taking a peek at those, but best of luck on the assignment. I will zoom out so you can kind of take it all in. But yeah, let me know if you have any questions and just really pay attention to those special cases and special situations. If you need to graph, that may help you kind of visualize your answer. So best of luck. We are done with chapter 1.